Today, let us look at the cross multiplication method of solving a pair of linear equations. Let us recall from the last class. We took two equations x minus y equals 1 and 3x plus 4y equals 10. Then we multiplied the first equation by the coefficient of the y variable in the second equation. Similarly, we multiplied the second equation with the coefficient of y variable in the first equation. Then we subtracted these equations and rearranged the terms to find the value of variable x. Now instead of solving for x, we wrote the value of x in terms of the coefficients a, b and c. So we represented the first equation as a1x plus b1y equals c1. And we represented the second equation as a2x plus b2y equals c2. And we found a formula for finding the value of variable x. We did a similar exercise with the coefficients of the x variable and found a formula for finding the value of variable y. Now let us look at these formulas once again and rearrange the terms such that the right hand side of these equations is the same. So we get x upon b1 c2 minus b2 c1 equals y upon c1 a2 minus c2 a1 equals 1 upon b1 a2 minus b2 a1. But how do we remember this formula? Well, let us rearrange the third term. Let us multiply it with minus 1. So the numerator becomes minus 1 and the denominator becomes a1 b2 minus a2 b1. Now let us write the coefficients a, b, c. Now the first part of this equation, which is for the variable x, we shall choose the coefficients that do not have anything to do with variable x, which are b and c. So we are going to write bc and apply the subscripts 1 and 2. So we get b1 c2 and the next term is b2 c1. Now let us look at the second term. We are looking at variable y. So we shall choose the coefficients c and a in that particular order. And once again, let us add the subscripts 1 and 2. So c1a2 minus c2a1. Next, let us look at the third term. Now this term represents the constant in these two equations. So let us take the coefficients a and b, which have nothing to do with the constant term. So let us write ab and attach the subscripts 1 and 2. So we have minus 1 upon a1 b2. And interchange the subscripts minus a2 b1. Now sometimes you may not like the minus 1 in this equation. So that's okay. Take the constant terms in both equations to the left hand side. Now the right hand side of our formula has a plus 1. So you can choose either method to remember the formula. If the constant terms are on the left hand side, then my formula has a plus 1. However, if my constants are on the right hand side, then my formula has a minus 1. Both the formulae are correct. Let us choose the first set of formulae and look at the term a1 b2 minus a2 b1. Now for this fraction to exist, this denominator should be non-zero. So a1 b2 minus a2 b1 should not be equal to 0. But if we rearrange the terms, we get a1 upon a2 is not equal to b1 upon b2. Does this seem familiar? Yes. This is the condition for a pair of linear equations to have a unique solution. Now this is very interesting. So if the denominator a1 b2 minus a2 b1 is non-zero, then that represents a unique solution for the given pair of equations. However, if this term was equal to 0, then a1 upon a2 would be equal to b1 upon b2. Now this is true for two cases. It is true for coincident lines as well as parallel lines. So we would have to check the value of c1 upon c2. So if c1 upon c2 was equal to a1 upon a2 and b1 upon b2, then that would represent infinite solutions to the pair of linear equations. If, however, C1 upon C2 was not equal to A1 upon A2 and B1 upon B2, then that would represent a pair of linear equations with no solution. Let us look at a few problems. A fraction becomes 1 upon 3 when 1 is subtracted from the numerator, and it becomes 1 upon 4 when 8 is added to its denominator. Find the fraction. So a fraction becomes 1 upon 3 when 1 is subtracted from the numerator. Let us write that as n minus 1 upon d. The next statement says that it becomes 1 by 4 when we are adding 8 to the denominator. So the fraction would be n upon d plus 8. Let us simplify these two equations. And we get a pair of linear equations in two variables, n and d. Now let us apply the cross multiplication method to find the values of n and d. But the cross multiplication method only works for variables x and y. So let us replace n with x and d with y. Let us substitute the values. And solve for x and y. So we get x equals 5 and y equals 12. So the fraction is 5 upon 12. Let us look at another problem. For which values of p and q does the following pair of linear equations have an infinite number of solutions? We are given two equations and the second equation has p and q in the values of the coefficients. Now for infinite number of solutions, let us recall the condition that we need to apply. We saw that a1 b2 minus a2 b1 should be equal to 0 and a1 upon a2 equals b1 upon b2 should be equal to c1 upon c2. So let us choose these two conditions and apply those here. Let us substitute the values for a1 b2 minus a2 b1 and equate it to 0. Let us rearrange the terms. And we get p equals 5q. Let us call this equation 1. We can actually substitute the value of p in another equation. Let us see b1 upon b2 equals c1 upon c2. Why are we taking b and c? Why are we not taking a? We could also take a1 upon a2 equals c1 upon c2. But we have already looked at a1 upon a2 equals b1 upon b2 in the first equation. Let us substitute the values and replace the value of p with 5q, which we got from the first equation. This gives us q equals 1. Substituting this value of q in the first equation, we get p equals 5. So for p equals 5 and q equals 1, this pair of linear equations would have infinite solutions. Let us look at another problem. Places A and B are 100 kilometers apart on a highway. One car starts from A, another from B at the same time. If the cars travel in the same direction at different speeds, they meet in 5 hours. If they travel towards each other, they meet in 1 hour. What are the speeds of the two cars? So we are given two places A and B which are 100 kilometers apart and one car is standing at each place. Now they are going to travel in the same direction and meet in 5 hours. In the second case, they are traveling towards each other and they meet in 1 hour. Now what are the speeds of the two cars? Let us assume that the speed of the orange car or car standing at place A is u kilometers per hour. And let us assume that the speed of the green car or the car standing at place B is v kilometers per hour. Now we know that speed times time equals distance. So when the cars are moving in the same direction, the orange car is always trying to catch up with the green car, and it is always trying to make up for the 100-kilometer distance between them that they started with. So the distance the orange car is trying to cover is 100 kilometers. If you've been in a car on a highway, then you might have noticed that while overtaking a car in the same direction, you need to go slightly faster than the car in front of you. Which means that the speed that you're driving at doesn't matter, but the increase in speed that gets you ahead matters. So the speed here would be the difference in these two speeds, u minus v. In the second case, when they are moving towards each other, again they are trying to cover 100 kilometers. But this time, the speed is going to add up. Note that they are going to meet sooner. So the speed is going to be more. So we are going to add the two speeds. We are going to say u plus v. You might have noticed this in a video game. When two cars are moving in the same direction, it is easier, but when two cars are moving in the opposite direction, it is much more difficult to navigate. Or you might have seen this in movies. So we have got our two equations, u minus v times 5 equals 100 and u plus v times 1 equals 100. Instead of u and v, let us write the variables x and y and apply the cross multiplication method. We get x equals 60 and y equals 40.